Hi guys, welcome back to another video. Peter Kennedy, Kennedy's Garage Portlaw. What do we have today? Hopefully a little fast video about it. 2011 or is it 12? I'll have a look there in a second. Mercedes Vito 2.2 diesel. What we have on the customer's complaint is check engine light on. You saw that, did you? 168,799 kilometers. No real drivability issues, but he has been in with a garage or something that has done a forced regeneration and a few bits and pieces like that on this car. Sorry, there's lad walnut blasting the intake ports on a Mazda here. What am I going after today? I'm going after that P2463 soot content of diesel particulate filter is too high. There's a component fault. P245414. The input for differential pressure sensor 1 in the diesel particulate filter has a short circuit to ground. There's a short circuit to ground or open circuit. Now these ones are malfunction indicator lamp on and stored and current. Okay, so I'm going to focus on these two today. This one, the connection for P225211, the connection for the signal line of oxygen sensor 1 has a short circuit to ground. There's a short or an open circuit. I'm ignoring that today. I'm just going to fix this and see what happens down here, okay? Fingers crossed. When this is potentially an oxygen sensor fault, hopefully these items will fix that item. Now, it's specific there's a short circuit, but in saying that, generally, you know, fix what you know you can fix and see where you can go thereafter. What am I doing? I'm going to get out. What the actual scan tool is telling me is soot content of diesel particulate filter is too high. And it says input for differential pressure sensor 1 has a short circuit ground. So I'm going to go after the differential pressure sensor here. We can get in here and have a look at pressures and just see. I did on a just ahead of schedule just a minute ago have a look at OBD, but OBD did not give me differential pressure readings. So because of that, we're going in here and we're going to just see what we find. All actual values we'll go to. Sensors, let's search. Is there a lot of them actually in here? Okay. We'll go with that one. Yeah, I'm just going to go with that one for Greg. Actually cancel. Okay. We're reading in bar. Because of that then, what I'm seeing 1.1 bar. That looks like it's huge pressure. Because 1 bar is 14 psi, 1.5 bar is 20 psi. I'm just going to stall this thing out and just see what happens. Okay, that's me stalling it out as I normally do. Okay, from the get-go, I would suggest that this sensor is reading atmospheric pressure first and then showing actual back pressure on top of atmospheric. So there is 1 bar of atmospheric pressure in the air, or 100 kPa. 1 bar we're seeing here. So I'm looking and thinking the pressure we're seeing thereafter is simply on top of atmospheric, if that makes any bit of sense at all. Okay, we'll get out, find and locate this differential pressure sensor and see where we're going to go and see what kind of attack process we're going to have. Fast pop out underneath the bonnet. Our exhaust differential pressure lives right back in there, if we can see, can we? Back here, I've actually just pulled it out. Can you see my bits of pipes just sticking up there? Mightn't be very clear, but I've pulled out my pressure sensor and all I was trying to do was get a bit of room so we could actually get a look at this thing, okay? I'm going to show you if you can see. Will you be able to see? I have numbers on it there. Can we zoom in? I'm going to zoom in a little bit more. Grab that again. If I can grab it on a little bit tight. In there, lads, I don't want to disconnect any. Right around, I'm upside down, sorry. Okay. Now surely we can see that. So, okay, so we can see 3, 2 in the middle, and 1. Okay, so black is 1, pink is 3. Okay, we come back up. A bit of component test or component information. Number 1 is signal, number 2 is ground, number 3 is 5 volt supply. So number 3, our pink wire, I believe, is going to be our 5 volt power supply. Middle one is going to be ground. I have a multimeter in hand just to do a little bit of checking. I've actually just bolted or crocodile clipped my ground lead onto the side of an engine there. I'm going to use this lead over here and I'm going to touch off battery positive and just see, right, with 12 volts. I'm off again. Okay, so we're going to get in, verify some of our wiring. What I'm going to do is I'm going to back probe both the middle wire and number 2 and number 3. Middle wire is ground. Number 3, our pinkish one, is going to be our 5 volt supply. Just make sure we have 5 volts coming to it. Then we'll back probe the number 1 wire to see what our signal is like. So, my light on. The long and short of it is everything that you see 3 wires going to are going to be basically just their own little sensor. So they need a power, they need a ground to work, positive and negative, and then the other one is going to be the signal that's going to come out of that sensor for whatever it's reading, whether it's fuel pressure or whatever, okay? It's generally just pressure sensors, but all sensors you're going to see on cars are going to be 3 wires. So here we have, I'd say a pressure sensor there. Look, we're going to have 3. In there we'd have basically 5 volts, ground, signal. No matter what we go on to, we're going to have the same thing. If we have an airflow meter in here, we're going to have 4 in that. I would potentially say the 4th wire, it could be a little bit different. Normally are 5, 3 for the airflow, 2 for the temperature. But in this case, I'd probably say we have maybe power, ground, what that power being used for the temperature sensor, and then it being a digital rather than an analog airflow meter, if that makes sense. Anyway, that's when I see 4 versus 5 wires. But on this anyway, we're going to back probe and just make sure we have our 5 volts. We might load test it with a test light, same with the ground, and just then make sure from there then that we can get our MIDI-vac, we can put pressure in there, can or can't see what's happening at the signal wire, okay? Ground in number 2, and what do you call it? Positive lead in number 3. That makes sense, does it? So our ground is here, and that's our, what we call the 2 leads basically for the multimeter in here, and we have 5 volts in there. I might load test them and just make sure. We'll check what's happening at the other signal wire. Test light crocodile clip on that battery positive, running over here into our middle wire. Load testing ground. Ground is good. Ground connected to the banana jack on the end of my test light now, and you can see our test light is lighting dimmer because it's only 5 volts, but it is lighting, okay? That's me actually just touching off it there. So, maybe I'm jumping the gun here a little bit, am I? We've tested or confirmed a good ground. We've confirmed a good 5 volt reference. I actually checked and I had 5 volts while the test light was on it. Okay, I didn't show that. But where I'm now rolling over to is in and onto the actual signal wire there on number 1. Okay, and in there I have 0 volts. So the question that everyone is going to be saying right now is, okay, right, well you've 0 volts there. Does that look like this sensor is shorted out? But how come we had changing numbers and they were quite high numbers? The reason I'm thinking it's a default number, okay? So I'm thinking there's a short on this circuit, and because there's a short on it, that the car is actually calculating its own pressure or thinking that there's pressure in there somewhere. And if it calculates it higher than expected, well, lo and behold, it'll kind of go into limp mode and give us overloaded faults and all that kind of stuff. What I'm actually going to do with the sensor stuck in there, I'm just going to see, which I didn't do this already for ye. Now I've been on this, so my frame of thought is slightly different than year one, which is probably a little bit topsy-turvy for you. Because I just thought maybe, it's only stupid, but maybe it might be worth a video for someone here if they're getting a DPF related problem. So like, what I would get is a phone call saying, look, the soot content of the diesel particulate filter is too high. It must be blocked. But it's not blocked. I can't find my manometer. I don't know, Alan must have it somewhere, but I can't find it. So because I can't find my manometer, I can't tell you the exact back pressure in there, but I do know it's small, just from connecting in a hose, feeling it, you know, and it's not big anyway, that's what I can tell you. But we don't have a block DPF either at this stage. I will do a clean on it because it's always good to do a clean on them and just to disperse anything that's in there. But it's not actually primarily our problem. The primary problem is going to be this pressure sensor. I'm going to erase these codes and just see what happens. We have a record of them here now. Let's see that they come back. Okay. The input for the differential pressure sensor 1 in the diesel particulate filter has a short circuit ground. Short circuit ground, normally what the cars would, the electronic side of the car will normally use kind of a, if they kind of have a 5 volt range. And if we use the bottom of my finger and the top of my finger here, the bottom of my finger is 0 volts, the top of my finger here is 5 volts. So the first 0.5 of a volt, the thickness of my finger, triggers a low voltage. The first or the last from 4.5 to 5, so we'd say in between my fingers 0.5, 4.5, bottom of my finger is 0, top of my finger is 5. Does that make sense? On a sliding scale. So we have the middle bit, 0.5 to 4.5 is the usable voltage that the car will use. Right now we see 0, so we have a short circuit to ground, if that makes sense to you. What I have here is I have a little MIDI vac. If I put in pressure in there, we have no change on voltage, and that is going direct into the actual sensor in there, if you can see it just run inside. Okay. Yeah, is that all questions answered? I do not know. I'm hoping that I have them covered. I have actually gotten a part number from that. I've ordered a part. It's a Hoffer part, but it was ordered as a Bosch part from the part number, okay? Here's our part number. 0281006 Make sense of that, you can? And the part number on our sensor is the same. I have a pipe stuck on, so it makes life a little bit... you can't see it, but anyway, it is in there, okay? Yeah, that's it. Time to fit this thing and just see what happens. See, can we manipulate the changes in the signal wire readings we're getting, and see, can we get rid of that fault, and also see what our back pressures look like in real terms rather than calculated terms. I've just swapped out my sensor, so there's the old one. New one is just sitting nice and cleanly down there. My same back probing pins are in the signal wire and the ground in the middle. I also have a little pressure pipe running up and up to my MIDI back, okay? The minute I plugged it in, lo and behold, I had 0.57 of a volt, which you can see there. So that's anything below that was our short, i.e. that one there. Internal in the sensor or whatever it may be. It's not the actual wiring of it. If I turn around and give ourselves a little bit of pressure, but both of these may be in the same shot, will it? So leave off pressure, a little bit of pressure, a little bit of pressure, a little bit more pressure. So we're at 2 volts there now. So what do I see in here? If you can see it, PSI, what, just over 5 PSI, just under 50 kPa. We have around 2 volts in there. So we see some little bit. We might grab a scan tool. Was I looking at live data? I'm going to erase codes. Yes. Because we know at this point in time, it's short is gone. Okay, brilliant, that's gone. Live data, but just go and see what happens. Actual values. I don't know. It's funny one the way. No escape. I don't want that, do I? Yeah, all actual. Okay. All actual values, sensors. It's funny the way we were seeing. Okay. So we're only wanting that. Show selected. Here we go. We'll have a look. Say hello to Marvel. Hey, Marvy. Just see what happens. Actually, do you know what? Which is weird. Because I'm just looking at, because we had the pressure in there, and when I had the pressure in there, in here, I wasn't seeing it here. Look at this. This is like ghost information or something. So I'm applying pressure here, but my live data is crackers. What do you do with scan tools, eh? Is there an exhaust pressure sensor somewhere on this thing? The only pressure one we had here. There's very little on this. I actually tried but it was acting the silly billy, so I didn't use it. The only pressure ones I have, boost pressure. You'd be thinking, the only back pressure PID we had, I'm thinking we'd be weighing a heck with that crack, would you? Anyway, that's leading us up the garden path. We have a fault for an exhaust pressure sensor. Differential pressure sensor. We have a fault in our exhaust differential pressure sensor. Fault wouldn't clear, fault done, but that thing is going to send us up on some kind of a weird thing. Maybe that's just like an exhaust pressure sensor on Mazdas or something. These jokes, there's a Mazda engine. Exhaust pressure sensor are normally... no, well that's it. That's our differential pressure sensor there, the 2.1. But our exhaust pressure sensor, which I can't see in here at a glance. There she is. Our exhaust pressure sensor is that, and they can be very, very high, those pressures. So maybe it have an exhaust pressure. I couldn't see any on it, so I just want to see exhaust back pressure. I was presuming it was not that, but that. Anyway, okay, so here we are. We have a problem found. We have a problem fixed. I'm going to have a look and just see have I something else. It's mad, isn't it, the way they won't give you differential pressure. Anyway, the joys of cars and trying to make sense of what they're telling you. New sensor in and in place, and started it, ran it, and we got a 246309. The soot content of diesel particulate filter is too high, so that was one of the faults we were having. We are after getting that back again. So what I'm going to do, I can't actually see live data, so I have grabbed the top down that I'm going to go, and I'm actually going to go and have a look and see will that give me differential pressure. So I'm going to hot functions here and into exhaust after treatment. I didn't even put it out of the garage yet. It came back after a couple of snaps of the throttle. Come on. I didn't do my clean yet, so I may, as I said there, I may do a clean at this point. Let's see if I can get my back pressure and my ignition on it. Hey. Okay. Initialization after component replacement. I'm going to click on that diesel particle filter. Insert. We'll click on that. Teach in process on the charge air exhaust system is leaking this also. Please press OK to continue. Okay. Note, this teach-in process shall be carried out after replacement of the following components. We have our diesel particulate filter differential pressure sensor. We've done that, so we're going to go OK. Preconditions for the teach-in process: ignition on. We are on. Come on. Watched pot never boils. If I've been on comments or slow on responding to comments to any of you lately, I have a job going on above my house, and because of the job going on above my house, I'm every night doing stuff. So because I'm at other stuff, I'm just finding it hard to go and take time to respond to comments. So I think I've got through good for them this weekend. Adaptations have been reset. Okay. Might do that as well. We're going to say that we have replaced the diesel particulate filter. Okay. Actual values, teaching new diesel particulate filter. We're going to say that we had a new one. Conditions for our learning process: engine is not running, ignition is on. Okay, that's where we're at this point. Turn the ignition off. Oop. Okay. Okay, you don't want to stand watching that, so like magic, that's going to jump from 23 to 0, just like that. Turn the ignition on. Okay. adaptations have been reset. Okay. Just 1 second. Right, we're back and running anyway. We're going to I have to go and talk to a chap there after popping in to talk to me, so I'm going to have a look and maybe swap onto the top done. Okay guys, top done for the win once again. Sorry, I done a DPF clean. I'm trying to get my reflection out of this thing, if we can get it. Oh, holy God, will you stay there somewhere? Pressure differential in the diesel particulate filter. Now I cannot see an exhaust pressure sensor on this, but lo and behold, we have an exhaust pressure sensor reading. So we are kind of either going maybe a little bit topsy-turvy about this, because I was thinking that this was going to be my exhaust differential pressure, back pressure, same kind of type thing. But anyway, look, this is phrasing it differently. This is the second time that the Top Don has gotten better information than both the Snap-on and or the Autel, because I had a fuel pressure issue on a 1.2 Nissan Juke there recently. My manifold absolute pressure was 10 kPa on all other scan tools, and the Top Don had it at 100 kPa. Here we have differential pressure on the Top Don, not on the Autel, not on the Snap-on. So lo and behold, anyway, sitting here at idle, we have 10 hectopascals, which is bang on the money. Okay, 2000 RPM. My car's rolling away on me. Okay, 2000 RPM. I have done a clean on this before I went for a drive. We've seen our change in there. 20 HPA, just above 2000 RPM. Is this a calculated crack from that crack? Grams of soot really low. Anyway, the DPF clean, pressure sensor, and whatever the heck resolved this thing. Thankfully, we've proved the sensor bad when I couldn't get the numbers to change from it. Even though the scan tool live data was wonky, we proved powers and grounds to it good and replaced the sensor, fitted a new one, done a DPF clean, didn't know the back pressure, couldn't find the manometer. Anyway, the joys of this industry when you're thrown in the middle of the bits of cars all over the place. I showed you an engine and a Mazda that I was on, jumping from that into this. Lo and behold, problems fixed. Going to do another couple of miles. Going to do, 20, 30, 40, 168,000 kilometers. Going to do 20, 30, 40 miles in this, or kilometers, whatever it may be, just to make sure everything's all right. I'll drive it home tonight and make sure that everything's good. But for this one, lads, please like and subscribe. Exhaust pressure, differential pressure sensor on a Mercedes Vito, actually 2012. All right, guys, talk to you later on. Thank you for watching. See you next cartoon.